they lose their value. So you're losing around 17% of value every year. That's going to be my decay factor. This is my initial value because that's how much it's worth now. And how much is it going to be worth in 6 years? Well, that's the final value. If you want, here, I'll get that equation here so you can see what it looks like. Okay. So now, final value, that's what we're looking for. We don't know, it's question mark. Initial value is $1,400 times decay factor. Decay factor is not 0.17. Remember, it's 0.17, and then you take 1 minus 0.17. That is my decay factor. A lot of students make that mistake there. This is going to be 0.83, I believe. And number of periods. So this is every year. How many years then? 6 years. That's it. Now it's just a calculation. Get your calculator out. You got to know how to input exponents in your calculator. It is difficult for some, so you have to practice. The final answer is $457.70, and we're rounding to 2 decimal places. So final value is around $457.72. That's how much it's worth in 6 years. Half-life models. So half-life is a type of exponential decay, so it's like your decay model, except half-life is unique as the decay factor is always 0.5. The exponent needs to be calculated as shown below. So half-life is just a specific decay model, and this is the formula for that. So let's do this question here. So you have a radioactive substance, has a half-life of 16 hours. How much of a 95-gram sample will remain after 4 days? Okay. Half-life is pretty easy usually because the growth factor, sorry, not the growth factor, the decay factor is always 0.5. So you don't have to figure that out. The final value, once again, we are looking for our final value. We don't know. The initial value in this case is 95 grams. And we have times 0.5 to the power of, this is the tricky part with half-life, figuring out the exponent. So it's the total time divided by half-life time. So what's total time? Sample will remain after 4 days, and the half-life of 16 hours. So half-life time is 16 hours. That's here. 16 hours. Total time is 4 days, but hours and days aren't the same units. This is important, and I was waiting for an example to make this point. When you're dealing with these types of questions, make sure your time is always of the same units, or you have to convert it into one. Meaning you have to convert the hours into days or the days into hours. Usually it's easier to do days into hours because all you have to do is, well, there's 4 days and there's 24 hours in a day, so 4 times 24. That's how many hours, there are. So that's going to be 96. So this is going to be 96 hours divided by 16 hours. So total time half-life time. 96 divided by 16. Well, that's a pretty nice number. It's 6. So just an extra step here. But once you get to this step here, it's the same as usual. You just do 0.5 to the exponent 6, whatever that decimal is, then you times it by 95, and the final answer is 1.48. So final value, 1.48 grams is remaining after how many days? 4 days, I believe it was. Yes, after 4 days. So if you start with 95 grams, around 1.48 are remaining after 4 days. All right, recap. By now you should be able to graph exponential relations, identify exponential relations, solve exponential growth or decay problems. Now what? You have 3.4 and 3.5 to work on, and then you have the due tests that are due today. So here. So we always go to the course outline to see the stuff that's due. And here we have Unit 3 Task 2, exponential relations, and there's 2 of them. So what I'll do is, in case you don't understand that, there's 2. There's one that's thinking, and one that's called communication. So hopefully there's no issues there. And then there's the quiz as well. Don't forget the quiz. Any questions? So another question about graphing, just a quick recap. Our base value is 1/2. Our exponent is x. How do I find my x values? These are something you have to memorize. So remember, just 0 is like, the middle value there. Just go 1 above, 2 above, 1 below, 2 below. That's how you find your x values. That's how you start. So this is something you have to memorize, something you have to know. Now, once you have these numbers, you plug them into the equation. Y equals 1/2 to the power of 2. So 1/2 to the power of 2, that's 1/2 times 1/2. And if you do that in your calculator, you'll get 0.25. 0.25. Then we have y equals 1/2 to the power of 1. Anything to the power of 1 is just that thing, 0.5. 1/2 is 0.5. Anything to the power of 0, that's just 1. And here's the tricky part. 1/2 to the power of -1. What you need to do is you need to flip that fraction, and it becomes 2 over 1. And here we have y equals 1/2 power of -2. Same thing, you flip that fraction, it becomes 2 over 1, except the exponent is 2 now instead of 1. So since the exponent is 2, 2 to the power of 2 is 4. Once you have your values, you go to your graph, you draw a nice little dashed line here at the x-axis, and you plot the points. So 2.25 is very close to 0. 1.5 is here. 0 and 1 is here. -1 and 2 is here, and then -2 and 4 is here. And we know it's kind of going like this. If you need more points, you can draw more points. We know it's going something like that and like that. That's how you graph an exponential function.